Okay, next we have Professor Mark Jessel speaking to us about the West African Exploration Initiative, 10 years of integrated research for development. Just a quick introduction for Mark. We have, Mark Jessel is a professor and West Australian Fellow at the Centre of Exploration Targeting at the University of Western Australia. His scientific interests revolve around microstructure studies, the L platform, integration of geology and geophysics in 2 and 3D in the WA in 3D project, and the tectonics and metallogenesis of the West African craton, and this is WAXI. He recently completed a West Australian Fellowship, is focused on improving the links between geological and geophysical data analysis in 3D via analysis of the geological and topological uncertainty. Thank you, Mark.
Thank you, and thanks for being invited to give a talk here, and again, thanks for those people that have stuck around. As you can see, this is a real team effort, and I'm going to be talking about 10 years of research, so I'm not going to go into too much nitty-gritty. But I will acknowledge people as I'm going along, because most of this isn't my work. But I just wanted to start with the first integrated map of West Africa, which is, of course, what I'm talking about, which comes from Henri Hubert in 1933. And this was not just amazing because it was such a large area, but it's actually all based on his own mapping. So this is based on maybe 15 years of his own mapping. And it's just to acknowledge that, you know, whatever we're doing in the last 10 years wouldn't have been possible without the previous 70. What I'm going to talk about, I'm not going to go into a geology lesson, but just to say that this is the West African Craton. It covers 12 countries. It's got 2 Archean roots. It's got Paleoproterozoic greenstone belts, and it's got Mesoproterozoic and young cover basins. It's 2.5 million square kilometers, so it's like Ontario and Quebec put together, but as I said, it covers 12 countries. And this is it's slightly old now. This was the peak of exploration in 2013. It shows where Australian companies, the yellow dots where Australian companies were exploring back at that time, and you can see there's a phenomenal number of permits were taken out at that time. On the right-hand side, you can see the universities and that were teaching earth sciences at that time, and it hasn't changed since then. And that's going to become important as we go on. And we can see that in West Africa, there are relatively few earth science institutions available to carry out research. So the aims of the project from the beginning were to enhance the exploration potential of the West African Craton. So this is really important because we're not talking about solving a specific geological problem. We're not talking about collecting a specific data set. We're talking about enhancing exploration potential. And so part of that is to do with data, of course, and models and interpretation, compilations. But the other half of improving the exploration potential is to assist the local geological surveys and universities in their role in collecting and providing pre-competitive data information. So just as Matt talked about before, there's 2 aspects to this. There's data and there's people. And this project, at the very highest level, is integrating both of those aspects. Just, I can't thank all of the partners individually, as you can see, but there are 3 main groups. They're the industry sponsors and government sponsors, bottom left. There's all the research and capacity building groups, NGOs, universities, geological surveys on the bottom right, and at the top, the geological surveys and ministries of mines that have worked in this area. So it's been quite a large project. We've had over 70 organizational partners in the project over the life of the project. Just to summarize the project, so in case I don't get to the end, it's covered 12 countries, 73 partners, over 80 publications so far. We've had over 90 students and postdocs. We've built up a very large exploration database. We've been running over 1,800 people a day of technical training in West Africa, and we've remapped 650,000 square kilometers using geophysics. And I guess that's why I'm here today, is because a lot of what we've been doing has been absolutely involved the integration of different geophysical data sets with the geological data sets, and I'll talk about that a bit. So we can split up the whole program into a research component and a capacity building component. I won't go into the details here because I'm about to run through them. If we look at the methods we've used, a lot of the methods are overlapping, and a lot of them involve geophysics. If we take the whole project in the research side, it falls into architecture and timing, so looking at the structure and timing of events, and we've used seismic tomography, MT, M-gravity, numerical modeling, magnetics, radiometrics, satellite data, digital terrain models. We've used all of these data sets together because as Matt said, no one of them was giving us the answer. In terms of mineralization, there's been a lot of deposit scale studies, and we've also had a significant research program on looking at the regolith, because in West Africa, as in many other interesting parts of the world, the outcrop is actually pretty awful. So it's been a multi-scale, and in fact, I think I'm giving Matt's talk again. It's a multi-scale analysis. At the largest scale, at the top diagram that we have here, this is a seismic tomography slice at 325 kilometers, showing that the roots of the craton actually split up into 2 or arguably 3 different domains, suggesting that they're fundamental lithospheric breaks in the West African craton that will help us to understand what's going on. If we go down to the belt scale, this is in northwest Ghana, and this is actually not a geological map, it's a metamorphic map showing us where the important metamorphic breaks are in this area, and that's one of the things that we've really focused on. Of course, we've got deposit scales, and I believe that's Stefan Peruti there, not quite sure, it's a bit fuzzy, who's in the audience, looking at the Wassa deposit. And we've gone to the grain scale, and this is an EBSD image, so it's actually showing us variations in subgrain orientation within a single arsenopyrite, which was used to correlate with the gold content and to help to explain the multi-phase gold WAXI system, also in Ghana. As I said, we'll start at the top, looking at the regolith. This is the work of Jean-Louis Grimaud from Toulouse, who's taken the current digital terrain model, calculated the digital terrain model for 12 million years ago based on paleo-laterite surfaces. And from that, you can calculate how much erosion there's been, what the paleo drainage was, and what the paleo slopes were, which of course is a very useful tool when you're trying to understand the soil geochemistry in your region. As I've said, metamorphic mapping is incredibly important here in northwest Ghana and here in the Sefwi Belt in central Ghana. And we can see that many of the deposits are actually falling on major metamorphic breaks. And this is incredibly difficult work. You can't just do this stuff in the field. You have to bring it all back to the lab, do the geochemistry, do the modeling. But we've turned out to be incredibly powerful in improving our understanding. And in particular, it's shown that there have been major extensional episodes in the tectonics of West Africa that we weren't previously aware of. We've also done a lot of work on correlating different deposits. This is from the Ashanti Belt, showing time as a vertical axis, and all the yellow bands are the different gold mineralization events. So we haven't just been looking at single deposits, we've been integrating these different results in space and time in order to understand what the major timing of gold mineralization is. We've also done a lot of stratigraphy synthesis, and again there's this emphasis on trying to treat large areas, not just a single belt, but the whole of West Africa as a single system so that we can understand what the correlations between these zones are. And this is the work of James Davis, and it's the stratigraphic synthesis of the southern West African craton. It was too big to fit on one slide. And we can see the first-order similarities and the second-order differences between stratigraphic units across the craton. We've also compiled all the geochronological data, and this is a slightly unusual diagram because it's plotting age against longitude. And what this has shown us is that there's a 50 million year diachronous variation in the geochronological events that we were able to match as you go from east to west in the craton. Since all of the gold, most of the gold associated with the major deposits in West Africa is quite late, this is telling us that there's a significant age difference between the mineralization in the east and the west, likely to be related to this tectonics and magmatism. So this is a session about integration, and I'm going to talk about 4 examples of how we integrate our data. And the first example is the simplest, is we just stick it all in the same place. So the exploration geoscience GIS is something that we've built up over the last 10 years, and for 10 years now the sponsors have been able to access this data via an online GIS. So this is a web page, it's not ARC or QGIS or MapInfo. And so that they can access the data as we're collecting it. Every quarter, as we get new data sets, we upload it to this secure portal, and the people can download the data. Once a year, we also, of course, provide it on a hard disk because it's easier to get all at once. So this is not just data that you can see, you can actually download it and use it as you're going along. That's enough of that. Of course, I talked about the 1933 map. This is the 2017 map, and it's geophysically constrained mapping, which means we're going out in the field with our geophysics. We're not just relying on the outcrop, which is otherwise we'd end up with the same maps as everybody else. And we're using the geophysics to interpolate gaps, but also to better understand the structures. And even though this work has been carried out by a number of different students and postdocs, because we're using a harmonized lithostratigraphy and a harmonized legend, we're ending up with a map of the Birimian that's covering the whole of the southern part of the craton. We've also taken this into 3D, and this is the largest of our 3D models. We've done a number of models more at the district scale, but this is the model of West Africa at the scale of West Africa. And so at the top here we have Morocco, down here we have Ghana, and we're going down literally thousands of kilometers. This surface here that's blue and purple, that's cutting through everything else, is the base of the lithosphere. So again, we're trying to think at multiple scales in the same team, and we're not explorers, we're not trying to find the next deposit, but we're trying to provide information that allows explorers to understand their region better. We've also been developing a Geodynamic Atlas, and this is all a bit flashy and goes a bit quickly, but the idea is to be able to make time slices, spatially coherent time slices that show the evolution of metamorphism, volcanism, intrusions, mineralization, deposition of volcanics and sediments, and deformation events as a function of time, so that we can see the evolution, and you can see that there's variations from east to west, there's also variations in orientation of deformation, and these are fundamental constraints on any geodynamic model that we want to develop for the area. And of course, we are developing those models, but I'm not going to talk about them here. So that's the data side. The data side, we're integrating all of these different information, all the information that we compile, all the information we collect, into a series of products which are directly available to not just the industry which is supporting us, but also the geological surveys in the region and the universities to carry out further research. And now I'm going to talk about people for a few minutes, because that's part of the process. If we want to make West Africa more attractive to investment, the geological surveys have to be able to provide the data in more useful formats. They have to make it easier to provide access to the data, and there has to be a trained workforce. And so this is the training courses. We run 3 or 4 a year, and these are open to the sponsors, but also to the youth surveys and the universities on a whole range of technical topics. And I guess what distinguishes these workshops from ones that we'd run in Australia, for example, is that we're always using local data sets, and that has a huge impact on the uptake of the information, because the people, the geologists that are there, know these greenstone belts, they know the regions, and they're much more engaged in the process than if I show them the Yilgarn, which means nothing to them. We've also, as I said, had a large number of students, and these is the location of where all the projects have been over the last 10 years. And you can see there's some countries we haven't gone to, either for logistical reasons or for security reasons, but otherwise we've got a pretty good coverage. And these students themselves are starting to take up new positions. And so on the left-hand side, we have all the different universities, both inside and outside Africa, that have been trained using, in collaboration with the industry partners and ourselves. And on the right-hand side, it's the different companies that have hired people that have gone through this training. And so we can see that there's the next generation of explorers and researchers in West Africa and elsewhere are going to be trained in these integration techniques. So just going through all the different multis, there's multidimensional. We're looking at one-dimensional geochronological data, the map data in 2D, the 3D geological models. We're looking at multiscale, as I've said before, and that's been very important that we've been working together as a team. Even though the researchers are spread a bit all over the globe, there's three different groups in Australia, there's 2 different groups in France that are primarily doing the work, but we're working together so that we can share the students and share the techniques that we're developing to come up with coherent stories. They're multi-data, and as you've seen, they've been using a lot of the geophysics. I'd say, you know, and this is a question that we get, what's really been useful? And that way you can't ask me that question, Mark. What's really been useful to us in West Africa? The magnetics, yeah, but the best data set that we have is frequency domain EM. And that has really picked out the differences in the different units where we've got it. Unfortunately, there isn't that much coverage of frequency domain EM in West Africa, but if you've got to fly something, I recommend you fly that rather than magnetics. Radiometrics has been really good as well, and of course it's very good for the regolith story. And the regolith story in West Africa is so important because 80% of the ground is covered by something that really isn't what you want it to be. Multiple hypotheses. We're a big group. We don't even agree on what the tectonic setting of West Africa is, and that's an entertaining conversation that, you know, is something where there isn't one answer because it's under constrained problem. We don't have enough data to say it has to be this tectonic setting or this, let alone this tectonic evolution. So that's an ongoing question as to, you know, what was the importance of subduction, and if there was subduction, where were the subduction zones? What was the early tectonic evolution of the zone? These are works in progress. And finally, multiple organizations. And the multiple organizations, they're research groups in universities, they're geological surveys, both inside and outside West Africa, the exploration companies. We've been involved with a number of NGOs as well, both for research purposes and for the capacity building training. And I think this is something, you know, if there's something I've learned from this project is that it takes time for these different groups to understand what drives the different groups. And all these groups have different drivers, why they're there, what their KPIs are. But in the end, because we go back to this idea of improving the prospectivity of West Africa, the exploration potential, they all have a common interest because they all want that. And so that it's taken us 10 years, it didn't take us 10 years, but it certainly took us 3 or 4 years to get to that common understanding that even though the companies want one thing and the governments want another, in the end, they both want the same thing, and that's improved research capacity and knowledge base. So because it was such a good idea and because I'm not all that intelligent, we're trying this again. And so in South America, there's a project floating at the moment to look at the Guiana Shield and northern part of Brazil with the same logic, with the same types of questions to be asked. There's a number of different countries, there's 5 different languages, there's very different levels of data availability, and so we're looking to do a pilot project in that area, and that's the end of the advert. All else, the only other 2 things I want to do is to thank all of the researchers that have been involved in this, and I'm not going to name them, you'll be glad to hear. But all of these people have contributed to this project, and without these people, we certainly wouldn't be where we are today. And finally, of course, to thank all of the sponsors and the sponsors in kind who have provided us with more or less continuous funding over the last 10 years. Thank you for your attention.
Thank you, Mark. Any questions for Mark Jessel?
The question was, how do non-sponsors access the data? By becoming sponsors. Simple as that.
Hi, Mark. Just a quick question. You mentioned the frequency domain EM as being the favorable data set. What specific system? And was it mainly used, was it a deep penetrating system? Was it shallow? Was it used for supporting the mapping?
It was a GTK system, if you're aware of that, and you can probably tell me what the parameters are better than I can. And it was fairly shallow, but it's within the greenstone belts themselves, compared to the Yilgarn, for example, where the magnetics shows a high degree of variation. So we're just saying that the petrophysics was favorable. Yeah. In West Africa as a whole, the petrophysics isn't particularly favorable. And it's also confused by the fact that it's very low latitude. We're actually at 0 at the magnetic equator in Burkina Faso. And that complicates the interpretation. I mean, it's not impossible, but it's just, there's certain things that are more difficult to recover. But just the electrical variation in properties within the greenstone belts in the areas where we have the data has been exceptional. So it's just telling us that the petrophysics for electrical is better than the petrophysics for magnetics in these rocks.
Yeah, okay, thank you.
We've got time for maybe another couple of questions, if there are any. Okay, well, in that case, we'll move on to the next speaker. Thank you, Mark. So our next...